Okay, so we are starting chapter 5 today. It's solving systems of equations by graphing. A system of equation just means more than one equation, all right? So we're basically going to graph two equations on the same graph. We're going to see where they cross. Sounds like it shouldn't be too challenging considering we just did a whole chapter on graphing, right? Okay, we're going to do another lesson on Monday. Tuesday, we're going to review in class. No homework over Thanksgiving, but you will have homework tonight, okay? I'll think about it. All right, so let's try to get this done. So the first example just says, is the ordered pair a solution for the system? So if a point is a solution for a single equation, what has to happen? You plug it in for x and y?
Yeah, this sounds about right.
How do you know if it's a solution?
2x and 1y.
You do 2 times negative 3
If they have the
and
same
put the 1 in for y.
So yeah, if you plug it in for the x and the y and it works, it's a solution for one of the equations, right? The only difference today when we're doing systems is you have to plug it into both and see if it works.
Yeah.
Has to make both of them work, all right? So 2 is my x, 1 is my y. Plug it into the first one. If it makes this one true, we'll plug it into the second one. If it doesn't, we can be done, because if it doesn't make one true, it doesn't really matter. It's got to make them both true to be a solution. All right, so negative 3 times 2 is negative 6. And negative 6 plus 7 is 1. So it works there. Now we're going to see if it works in the other one. So plug it in again. 4 minus 3 is 1, so it's true. If it makes them both true, then yes, it is a solution for the system. All right? And I need to see all of this. Some of you are getting a little lazy with showing work. And it's really starting to affect the quality of your answers and the amount of partial credit I can give you. So just get in the habit of showing work again if you've gotten a little lazy with it. Questions? All right, here's the next one. So once again, I am going to plug the ordered pair in. So I'm going to plug negative 1 in for my x's, negative 7 in for my y's. So in the first one, I have negative 1 minus negative 7 is 6. So negative 1 plus 7, which is 6. So 6 does equal 6, right? So that's true. Let's check the other one. So over here, we have 3 times negative 1 minus negative 7. So negative 3 plus 7. So that's 4, right? 4 does not equal negative 5, so it is not a solution.
Wait. So if one of them right and the other one wrong.
It's got to make them both true to be a yes. If it makes one of them wrong, it's a no-go.
No.
Questions? All right. This is in the bottom half of your notes. Pretty obvious, right? So when we have a system of equations, one of the following 3 things is going to happen. Okay? The most common one is the first one. It looks like that. The lines are going to cross each other. Okay? There's a different m. There is one solution. My answer is an xy value. Okay? So when the lines cross, the slopes can't be the same. If they're the same, we'd either have parallel or the same line. So different slopes, one solution. The solution is the xy point where they cross. And you don't have to draw the graphs exactly. Just sort of sketch that 2 lines are crossing. All right, if the lines are parallel, they look like that, right? Parallel lines just run same rise, same run, so they run right alongside each other, never intersecting. So they'll have the same M, but they have different B's. We talked about that at the end of the last chapter. Here, we wouldn't have any solutions because they don't cross at all. Solutions are where they cross each other. These don't intersect. They will have no common XY points, so you don't have any solutions. And your answer is either no solution or this symbol, which is an empty set symbol. It's like a 0 with a slash through it. Okay? Now, the third case is that you have the line and the same line right on top of itself. So if they have the same M and the same B, when you go to graph them, one line will just fall right on top of the other line. You have infinite numbers of solutions. All ordered pairs on the line would be solutions. You cannot say all real numbers because it's not like every single XY pair works, but all the solutions on the line. So all the ordered pairs that make one line true would make the other line true as well. All right, I'll give you a second to catch up. First thing we want to do is get them both into the same form so we can see if they have the same slope, if they have the same B, if they have a different slope, and so on. Okay? So the first one's good to go, right? Y equals 3x minus 8. I know that 3 is my M, negative 8 is my B, right? Okay. Okay, next line, we got to get it into y equals mx plus b. We've been doing this for a whole chapter now. So, what I did here, I added the 10 to both sides. No, I didn't. I subtracted 9x, right? And I added 4y. I know. I would have just probably subtracted 10 and divided by negative 4, but hey, here we are. All right, so here's what happened in that magical step. Add 4y, minus 9x, minus 9x. Is everyone still with me? Okay. What would you do next to get it into y equals mx plus b? Divide by 4. And if you wanted to do it a different way, that's fine. You should know how to do this by now to go back and forth between different forms of an equation. All right, now what's the slope? Negative 9 over 4. And what's the b? 5 over 2. Good. So if I graphed these, how many solutions would I have? One solution, and it would be an ordered pair. Good. So, like, the only way you'd get no solutions is if the m's were the same, but the b's were different. If they're both the same, then you'd have, all the ordered pairs on the line. But here, if I went to graph these, they have different slopes, so they would cross each other. And I would just have one answer. All right? So, one solution. And if you're stuck, look back on that table. It tells you exactly what you're looking for. Questions? All right, here's number 2. How many solutions does the system have? So once again, we're going to get it into y equals mx plus b. If the m's are different, we're going to have one solution. If the m's are the same, you got to look to the b. If the b's are different, you would have none. If the b's were the same, it'd be all the ordered pairs on the line. We down? All right, first one. Get the y by itself. What should I do?
Subtract 2x.
Subtract 2x from both sides. So y equals negative 2x plus 8. The m is negative 2. The b is 8. All right, on the next one, what am I going to do? Subtract 4x from both sides. Divide everything by 2. Okay, so what's my m? -2. What's my b? +8. So if I went to graph these, what would happen? They'd be right on top of each other. It's the same line. Same slope, same y-intercept. We have infinitely many solutions, is how you would answer this question.
A, how did you know right?
Infinitely many solutions.
For A, like, how did you know this one solution?
Now we're going to graph these. We're actually going to find the solution. This is like the big lead up to this, all right? What am I going to do on the first one? -x. Divide by -1. All right, how would I graph this? Oh, hold on. I'm getting ahead of myself. Let's get the other one in y equals, and then we'll graph them together. All right, so I'm going to subtract x from both sides. Then what? Divide everything by -2. This is like a -1 divided by a -2, which is a +1/2. This is a +4 divided by a -2, which is -2. All right, jump back to the first one. What is my m? 1/1. What is my b? -3. So to graph this, I go down to -3 on the y. I rise 1, I run 1. I rise 1, I run 1. This is where it is so important to make a very, very straight line. And I'm going to extend it all the way off the graph. Okay? For the blue line, what's my m? 1/2. What's my b? -2. So I'm going to start at the -2. I'm going to go what?
1 up, 2 over.
Up 1, right 2, up 1, right 2. And I'm looking for where these lines intersect. Okay, so the magical spot where these guys intersect is right here. That is the ordered pair. What?
2.
So you go right 2, down 1. So the ordered pair here is 2, -1. Now, I always check these, because it is very easy to make a graphing mistake. So I am just going to quickly in my head, 2 minus -1, would that give me 3? Yes, it would. -1, so 1 equals -2 plus 3. Is -2 plus 3 1?
Yes.
Yeah, so you can plug them both in. To the first one, it checks out. To the second one, it checks out. And now you can be 100% confident that that is the answer. What?
I was going to say, you want us to write down the ordered pair.
The ordered pair is the answer. The answer here is 2, -1. What are your questions? All right. Here's the next one. All right, what should I do? Subtract 3x from both sides. And then divide everything by -1. So we get basically all positives, right? All right, so what is my m in that equation? What is my b? 4. So I am going to go down to the 4 on the y-axis. 1, 2, 3, 4. Whoa, just seeing who's listening. You all passed. Way to go. All right, I'm going to go what? Up 3, right 1. Up 3, right 1. All right. Next line is already in y equals. If you want to put a +0 on the end to help you see what the m and the b are, go for it. My m is what?
3.
My b is what? 0. So I'm going to start at 0. I'm going to rise 3. I'm going to run 1. I'm going to rise 3. I'm going to run 1. Uh-oh. What is happening?
Parallel.
Yeah. Did I need to graph that to know?
No.
No. Why?
This is the slope.
Look at the slopes. They're the same. So I already knew it was going to be parallel. However, if it says solve by graphing, you still need to graph. Okay? What's my answer, though? No solution. It's the empty set symbol. So there is nowhere where these are going to intersect. There is no ordered pair that would make them both true. We knew that before we graphed, but we had to graph anyway to show it. Okay? And notice that they have different B's. If they would have had the same B, we would have started both of them in the same spot, done the same rise and run. We would have just ended up with one line on top of the other. What are your questions? Do we need more time?
No.
All right. Example 3, part C. All right, what now? I'm going to subtract 3x from both sides. So I have negative y equals negative 3x minus 5. Then what? Yeah, divide everything by -1. So y equals 3x plus 5. My m is 3/1. My b is 5. So I would go up 5. 1, 2, 3, 4, 5. From there, I will rise 3. I will run 1. I'm going to go off the graph, so instead, on the next point, I'm going to go back to my b, but I'm going to go down 3, left 1. Let's try that again. All right, questions on the red line. Sounds like a subway system. All right, what do I do on the next one? Subtract 1x, good. So 2y equals negative x plus 3, then what? Divide by 2, divide by 2, divide by 2, uh-oh. Negative 1 over 2x plus 3/2 is what as a mixed number? 1 1/2. I don't like mixed numbers, as you know, but for graphing, it's really the best way to do it, okay? So, I am going to go to 1 1/2 on the y. From there, I'm going to go down a whole space and then right 2. Down a whole space and right 2. All right. Now, the slope is 1 down, 2 to the right. But if you start halfway between 2 points, you'll go down a whole jump. You know what I mean? A whole rise, negative, down. That sounds more confusing than it is. If you're halfway and you're going down one hole, you'd be halfway on the next one. Okay? Now, it looks like they intersect at what point? -1, comma 2. Let's plug those in because I don't feel great about the way we graphed the purple line. And we're going to come back to it in about 30 seconds. But real quick, let's just plug it back in. So this would be -3 minus 2. Does that give me -5?
Yes.
-3 minus 2 is -5. So it checks out on this one. If I plug it in over here, I'd have -1 plus...
2 times 4?
Yeah, so this does check out. So it's good to go. Now, I am old, and you know old people like things a certain way, right? I automatically do y equals mx plus b every single time unless someone forces me to do something else. Now, if you're like, I don't like the b to be a fraction, what are 2 other ways you could have graphed this? You could have used you could have used an XY table. Remember those? Yeah. We just took the test yesterday. This should not be forgotten yet. You can, no. Oh yeah, one of them was, yeah. You could have graphed using a table. Do you remember the other way to graph now?
Yeah, but
What is it?
With the
0 to 4.
Yeah, with the x and y intercepts? Is that what you mean? No, you mean the values of the table, right? That's fine. This is one method we could use. Like I said, I'm old. Old people don't like to change. I always do this. If you're not a fan of this, you can use a table. You can use x and y intercepts. Plug 0 in for x, solve for y. Plug 0 in for y, solve for x. Graph those 2 points. So any of the methods we learned to graph, you can use those. I just always go y equals mx plus b because that's what I'm used to. So if you're not comfortable with this, especially with the fractions, do whatever method feels right. Okay? But in this case, it worked out just fine, and we found our answer, and it checked out. Questions? All right, so the first one's already in y equals, right? Let's get this guy in y equals. What should I do? Subtract 4x from both sides. Then what? Divide everything by -2. So -4 divided by -2 is 2. Positive 6 divided by -2 is -3. Anyone having any feelings right now? It's the same line. We're going to graph it anyway. So m equals 2 over 1. B equals -3. So go down to the -3 on the y. Rise 2, run 1. Rise 2, run 1. Okay? When I graph this line, Then I go to graph the other line.
It's right there.
I'm still going down to -3. Then I'm rising 1, 2, running 1. See how I'm just graphing a line right on top of itself?
Yeah.
You don't really have to do that, okay? Once you see that it's the same line, it's the same line. So, in your notes, how are we supposed to write the answer? Go back to your little table. If it's the same line, infinitely many solutions is the number of solutions, but how do we write the solution?
No
Pairs on the
solution.
line.
It's the bottom right-hand box that you wrote down. All the ordered pairs on the line.
So A-O.
No, you write all.
That's a long.
You're not sure. I mean,
So, to clarify, if it says how many solutions, you can say infinitely many. If you're actually giving me the solutions, you have to say all ordered pairs on the line. No, this will happen like maybe once a worksheet, so it will not take that long. What are your questions on graphing systems of equations? Today we learned what? Solving systems by graphing. Exciting. We will explore another method to solve systems on Monday. Here comes your homework.